Hi, my name is Michael,
And I'm Ceci.
and we're going to present you Factor ANOVA.
So the problem is, an engineer is designing a battery for a device that is subject to extreme temperature variations. The only parameter that remains is to select the type of material that will wrap the battery. He knows that the temperature can have a significant impact on battery life. Thus, he would like to know what effect the type of material has on battery life and what is the best material to give a longer and consistent life to battery regardless of the temperature.
Let's start with the variable definition. The experiment is conducted with 3 different materials exposed to 3 different temperatures. One dependent variable, that is battery lifetime, 2 factors, material and temperature, and 3 levels, 3 different materials, 1, 2, and 3, and 3 different temperatures, 15, 17, and 125.
So, the experiment tries to find out how materials exposed to different temperatures affect battery lifetime.
For that reason, the test selection is two-way analysis of variance because we have 2 factors and 1 dependent variable. Let's establish the hypothesis. Each null is going to be all means for all factors are equal, and each alternative, at least one pair of level, is different for at least one factor. Let's use R to calculate and establish the test statistic. Let's do it in R. First of all, now we have the data in an Excel file. Here we have the kind of material, as we can see, the lifetime expressed in hours, and temperature. We have 3 different temperatures, 3 different materials, and lifetime, as we have already talked. We have to save the file in a proper way to open it in R. We have already lost the file, and we have to save the file in a proper way. We go to Excel, we go to File, Save As, we name the file, we define our location, and we have to save it delimited, text delimited in an extension point txt. We go to save, replace, save active sheet, continue. Now we already have our file in .txt. As we can see, here we have our data. Now we have to go back to R. Now that we are in R, we have to upload our libraries. We type library gupload. We upload it again. Now we have to know what is the directory of the computer. So we type get wd. Now it says that our files are in that direction. Now we change our directory. We have to type slash desktop. Now we have to upload the data. The read.table. We have named our file like lifetime, so we write lifetime.txt, comma, header, true. We call the function data, and as we can see, our data is now in R, and we can work. First of all, we are going to name a variable that is going to be model. We're introducing data, and now we're analyzing with ANOVA lifetime. Lifetime material temperature and data. Here we use the lifetime because that's our dependent variable, and we call material and temperature because those are our factors. Then we have to type summary model. Now we have here a summary of our model, and as we can see here, we have there is no interaction between the two variables. There is no interaction between material and temperature, but the material and temperature affect directly in the lifetime of the battery.
Since the p-value is smaller than alpha, we reject H0. At least one pair of levels is different of at least one factor. So we can say as a general conclusion that first what we gotta do is to the test selection, then to establish the hypothesis, then calculate the test statistic so we can get the results. Statistically, material and temperature affect battery lifetime. However, there is no interaction between them. Temperature is a factor that depends directly of the place in which it is used. Hence, what we can control is the type of material that will wrap the battery.
That there is no interaction between them, so we are going to plot the means for each group. So we type plot means data. That's the name of our file. Data lifetime material, and with this graph we are going to see the relationship between lifetime and material because there is no interaction. There seems something is wrong here, so we're going to type it again. The error here is that we are not typing where is the material, so we have to write data and material, because in that way the program is knowing that material is in that table. Now, as we can see, we have, as Cici has already said, we have a longer lifetime with material number 3. So that's a good conclusion for this table. And finally, we are going to see the relationship between lifetime and temperature. Now, as we can see, the fewer temperature, the greater lifetime for the battery. So finally, we are going to prove that all data adjust to a normal distribution. For that reason, we are going to test it with Anderson-Darling normality test. So we type ad.test. Something is wrong because we haven't uploaded our library. Libraries, mirror test. So we do it again. And as we can see with this p-value, because p-value is greater than alpha, that adjusts to a normal distribution.
Entonces se borró el eje 4.
Now we have to plot
Ahora se lo
the
cuento.
graph model.
As we can see in this graphic, variance in data of each level is not constant. Therefore, what we suggest is transform data to make variance constant and have more reliable data. According to the following graph, there are some points that do not fit into the line. For that reason, we have to do an Anderson-Darling normality test.
And as we have already seen, the data adjusts to a normal distribution. Well, friends, that's all for today. We hope you have learned a lot of this ANOVA 2 factor, and we see you again.
Thank you for watching.